My name is Sean Cordero. Thank you for joining us today during the Zero Trust Summit. I'm happy to be here today to talk about something that is important in terms of the adoption of generative AI security and what it actually means when we are discussing how does one start to protect from inappropriate usage of some of these tools and also begin to manage and leverage these tools for better business and security outcomes. My name is Sean Cordero. I am a CISO in residence at Zscaler, and I've been fortunate for the last 12 years of my career to have worked very closely with the Cloud Security Alliance as the chair of the Cloud Controls Working Group. What have we learned regarding the adoption of secure generative AI consumption? The Cloud Security Alliance, as they have done for many years, continues to lead the industry in terms of driving adoption of new technologies and helping the industry itself understand what are some of the most at-risk areas and the methods and means that might be utilized to leverage some of these tools for new methods of attacks or new methods to impact an organization. When we look at the work that's come from the Cloud Security Alliance, some of the things that we've learned from their research is that so many aspects of what it means to leverage generative AI, both as an attacker and defender, is a combination of driving new insights from the perspective of the attacker, creating more sophisticated methods of exploitation, and bundled all of that together with a much easier to use method for interaction with the data and also interaction in the creation of net new types of attacks. What are the key things, however, when we look at the use of generative AI? One thing we have to be completely and very clear on is that these models are delivered and created with the intent of maintaining as much of the data as absolutely necessary, which in its learning stage is all of the data. And because of this, it creates a model where it is very difficult, if in some cases not impossible, to actually remove sensitive data once it's actually been moved there. On top of this, we see a different challenge, which is associated and very similar to the early days of cloud security. I remember in the days when brand new software as a service technologies were coming to the market, or even the early days of infrastructure as a service, there was a belief that all of the providers would create all of the necessary tooling and all of the necessary controls within their specific ecosystem. And while some of that is now true, we also know that because of their solution sets, they do not intend to solve for all potential avenues. On top of this, when we think about the adoption of early cloud and we compare it to adoption of early AI, what we're finding is that there is a continuous growth and usage of what one could call shadow AI usage, very similar to the original concepts of shadow IT that we've been dealing with for upwards of 30 years, or during the cloud expansion, where we were seeing a variety of new intentional or accidental data events, data exfiltration or data loss events that were simply caused by inappropriate or accidental misuse. When we think then about all of this, well, how can these models then themselves actually help improve both the attacker's perspective and also the defender's perspective? The NLP-based methods of interaction for a lot of these tools is what makes it so powerful. So we've all heard of prompt engineering and the importance of that when you're interfacing with these tools, and this can't be overstated. The more and more sophisticated these models get, which requires that they learn more and more data, the more capable they become at providing profound insights, sometimes with minimal prompting and minimal inputs. When we pull these together and we look at the two methods where this can be very problematic, the first and foremost is the obvious loss of sensitive data to these platforms where there is no control. And as was mentioned before, once it gets there, it becomes very difficult, if not impossible, to back that data out. And then when you think about, well, what is the other risk outside of the data loss? Well, you also have the empowering of attackers being able to utilize this technology to become better at what they do. A common challenge that we've seen in the adoption of cloud, and we continue to see in the adoption of publicly available and publicly accessible generative AI models, in this particular case, for the sake of illustration, we're utilizing ChatGPT, but it could be any of the public models that are available. What we find is that when you have an internal user that is attempting to perform a particular action, let's say that somebody is trying to optimize their code, or they're trying to get a better sense of what a forecast might look like, and they're providing sensitive data that would normally only reside within finance. These tools allow you to very quickly derive value from the data that you provided because it's also leveraging the data that already exists. However, once that data gets there, this is where we start running into these challenges, which is because it's a public version of this particular model. And to be clear, I am speaking about those that are shared, the same one that you and I might be able to access as a consumer. I am not referring to private models that are trained on smaller subsets of data, but this would be your generalized and publicly available models. This is a scenario where once that data is there, somebody intentionally or unintentionally is looking for details on a particular organization, can query through the NLP interfaces very specific and glean very specific outcomes and insights by leveraging the data that's already there. Sometimes it's simply a matter of how you ask it. And when we start seeing at what the risks really are and the impacts, well, we're starting to see it in the media as new attacks are coming that are leveraging some of this data. But we're also seeing the accidental, or what I like to think of, well-intentioned usage of these models, but then they lead to data loss scenarios. In this particular case, it was an unfortunate situation where Samsung had an incident associated with some of their sensitive data being placed in one of these models, and they made a decision that they would no longer allow the use of these models, at least not the public ones. And overall, the costs of these are just starting to be understood because the impact here is actually quite different than what you would expect in the case of a poorly configured infrastructure as a service solution or a poorly configured platform as a service or software as a service solution, where let's say hypothetically, one particular tenant might be exposed and leads to a data loss incident. In this particular case, the incident itself has already happened. It's simply a matter of the overarching impact and how much that data is then utilized, accessed, potentially by anybody that has access to the model. So I believe it's an exponentially bigger problem once it's identified that the data does reside there and can be accessed. Now, how are some attackers leveraging some of this technology to get a better understanding of attack surface? One of the most common things that we as security practitioners do is try to understand what the software vulnerabilities are in software. Well, tools like Shodan and others have existed for a long time that can effectively crowdsource some of this data, or they pull it themselves. What's interesting about the generative AI models is that they actually may already have this information provided to them, either through learning that it's been doing by itself or information that it's been provided through either one of the users or through another third party. And in this particular case, instead of trying to run a VPN scan and then go through the manual process of identifying which ones are the highest risk, why not just have the model do the work for us and tell us what are the highest risk CVEs that will impact my environment, or in the case of the attacker, that I can leverage to get a foothold on the environment. And this is where we start seeing that these types of technologies amplify, when used inappropriately, amplify weaknesses like the continued use of publicly exposed IP addresses, or in the case of VPN-based architectures, these technologies make that exposing of those weaknesses much faster and much easier. So then what can we do by leveraging some of these technologies for good, not simply for trying to do bad things? Well, first, one is we can actually protect the type of data that is leaving your environment. And we can also leverage this technology for getting a better handle on what your true risk posture is as it relates to your technology footprint, and allow you to be more effective as a security practitioner or operator by getting better insights associated with the use of cybersecurity tools. In the case of Zscaler, what we're actually doing is, if we think of the example of an end user that is attempting to place sensitive information into a particular publicly available model, because Zscaler's Zero Trust Exchange, which is the world's largest cloud for cybersecurity, sits in line of that communication path. What this allows us to do is actually allow and disallow the nature of the connectivity that is being permitted, allows us to filter the destinations to where it's going. We can even inspect the type of data that is being sent, the prompts that are being utilized, and then ultimately provide the security operations team or the data protection teams the insights that are absolutely necessary to be able to keep control over the secure use of some of these technologies. This is a very common issue that a lot of organizations have not had an opportunity to get ahead of, because the rate of use of these technologies is so unprecedented. We're seeing organizations get caught a little flat-footed on this particular challenge. And truth be told, it is not too dissimilar from the very early days of inline cloud protection, where at the time, if we rewind the clock 13 years ago, where these technologies didn't exist, today, with technologies like what we provide at Zscaler, we have already the base infrastructure, the base capabilities. We've continued to expand it and to address this very specific type of data loss scenario. So when you think of these three different methods of where these tools can be utilized for good, there's helping protect against compromise, there's helping to get control over, in the case of a potential compromise or inappropriate access, to restrict where and how they move, and in a scenario where you have accidental or intentional data leakage, to be able to control that as well. In the case of Zscaler, we are known as the leader in the industry on zero trust architecture. This is something that we have shown to be incredibly successful, and is one of the key ways that allows us to protect against some of these enumeration attacks that are now easy and trivial to pull off by simply interrogating one of these models that exist on the internet. In our particular case, when adopting a zero trust-based network architecture utilizing Zscaler's approach, the public IP address space goes away, which means that even if a query was made against particular vulnerabilities, those devices or applications or servers would not even be accessible. This is one method that we have been protecting against some of these easier to perform enumeration attacks. And when we think about, well, let's say that somebody was able to get into a particular environment. One of the biggest challenges when it comes to network segregation is the fact that it's so difficult to understand which device speaks to which server, speaks to which internet application, especially if you're dealing with a primarily on-premises like approach. And the reason for that is servers go up, they go down. Sometimes they're turned up very quickly, they're turned down. We have just-in-time workloads, and this has been the reality of the world for going on 20 some years now. But one of the most fundamental problems from a network security architecture is, how do I know that a particular employee, let's say in the audit and control department, is actually utilizing a particular application? What evidence do I have that they're utilizing it other than interrogating the server itself and looking for login events? What we've done utilizing machine learning, we've taken all of the questions out of this simply by looking at the data. Because we're in the middle of every transaction, we can enumerate the end user, the device that they're utilizing, the destination that they're accessing, and provide recommendations based upon the model that we've created for machine learning to recommend to the network security architect or the network architect where they may want to push a button to select a particular policy that then enforces a strict set of policies that really gets you closer, if not immediately, to that goal of achieving a zero trust based network access model. And this is one of the most difficult things for organizations to overcome, because the days of managing IP addresses in a combination of an IPAM or in Excel or any other version of these systems, those days are still very much with us. And the asset inventory problem continues to plague the industry. We took a step back and said, well, we already have an understanding of how these devices and users are communicating. Why don't we take what we're doing around machine learning and help our customers very quickly adopt these new policies that are capable, that are possible via Zscaler's approach. Now, some of the innovations that we've been creating and focusing on is, one is leveraging all of the signal intelligence that we're receiving across all of the environments that we protect and taking that cleansed data to get new inferences and draw new inferences regarding a particular environment. And we're calling this breach prediction. It's a capability that we've been working very hard on. The team's very proud of it. It's pretty impressive stuff, because you can actually look at your environment and we can provide a view based upon what the AI has learned about the environment to give you a sense of where you may stand. On top of this, we've also adopted a natural language processing model to make it much easier for our customers to very quickly ascertain where issues might exist in their environment. We're very quickly moving to a model in the future, and it's not just us, but I think the industry as a whole, where combing through logs over and over again and very complex SQL queries simply to try to glean an insight, I foresee very quickly that we will be mostly interacting with NLP-like models to obtain this information. And then on top of that, our best-in-class data loss prevention capabilities, we've continued to improve on this and starting to support multi-model capabilities. So the ability for us to detect sensitive data in moving pictures or different types of photographs, this type of information that can be used, or these formats, and media that can be leveraged as a method of data exfiltration. When we look at what we're doing on the breach prediction standpoint, we're getting a good sense of what end users are doing or potentially rogue machines or rogue devices or even attackers in some cases, and able to provide a probability score based upon what we're seeing across the environment. And what's really cool about this is that in the past, when we think about it as security practitioners, you have to draw all of these inferences from so many different data points and often across multiple teams. Think about how hard it is right now to obtain the latest vulnerability scans on a particular set of servers that are managed by a particular team. And then on top of that, correlate that with activities that are occurring on your network, potential signals that are coming in from outside of your network, let's say in your cloud, pull that together and then try to infer something meaningful from it. That's a really difficult problem. What we've done is because we're in the middle of the transactions, we're seeing the data, we're understanding how things are communicating, and we have our zero trust exchange, which includes our sandboxing and anti-malware, data loss prevention capabilities. We're able to have a higher degree of confidence in the way that we're predicting or giving a probability score as to how likely it might be. So in this particular case, we're seeing an example where a very particular end user attempted to download software. It led to an infection, and that infection in and of itself led to a variety of other compromises, in this particular case in S3. With the forecasting capability and the prediction capabilities that we've built using AI and ML, we're now able to predict and show you how this likely would happen if that was to happen. When we think of natural language processing interfaces and interfaces as a whole, this is one of the things that gets me the most excited because for years, as both a CISO, a operator, engineer, getting facts and data that's usable was always so difficult. I'd have to go to 5 or 6 different sources simply trying to understand where a particular machine might be. If you've ever had to chase down the layer 2 address on a network switch and then tie it back to an IP address and trying to figure out where a machine might actually lives and what server it's speaking to, you might have an appreciation for how difficult that truly is. You add security risk on top of that, it becomes not an impossible task, it just becomes a much more complicated task. What we've been building is an interface that enables our customers to interrogate their tenant and leverage the new interfaces that we're creating to gain these insights and simply asking it a question so you can then prioritize the most important things that is actually based upon your data and the method and modalities of access. And on the data protection side, this is an area that is been in play for quite some time. We've been doing some work here and continue to make new innovations here. We're all familiar with stenography as one method of data exfiltration, and that's been a long-standing method of data exfiltration. But we're also seeing new methods of leaking information. For example, why bother trying to send out a Word document that is full of sensitive information when I can just screenshot it and send it as a JPEG? Or why not use YouTube as a data exfiltration method by simply doing it the way that we see in the films from the 70s and the 80s, where they have a camera and they're just recording the sensitive information, and you use that as a method of data exfiltration. These are very real things that are happening, and we're building capabilities utilizing our ML and AI capabilities to not only detect it, but leveraging our data protection capabilities to prevent it as well. So looking forward, what's important here is that the growth of generative AI has truly continued to outpace even the growth of early days of infrastructure as a service and software as a service. It is important for us to acknowledge that the potential negative impact and also the potential positive impact is exponentially higher than anything we've really have come across, at least in the last 30 years. And it's important that we look at it with as much clarity as possible and have a good understanding of where this impact might fall into each of our organizations. And ultimately, understanding that the innovation that we're certainly driving and other organizations are driving around AI, the innovation is not just for the bad actors. We have opportunities as an industry to continue to do amazing things to protect organizations, to make security operations easier, more impactful, faster, more scalable. And these are the things that keep me very hopeful about the leveraging and the use of these technologies. Thank you for your time.